Welcome back, it's Becky. In today's video, I'm going to explain the process I use to transform an electronics project idea into a working Arduino sketch. Developing the code for your project can be the most intimidating part, especially if you haven't done it 1,000 times already. But you have to address it from the very start of the project, so let's just get started. First, and this may seem obvious, but write out the main purpose of the project idea. If it has multiple functions, decide which features are needed versus those that would be nice but aren't necessary at first. See also my previous video about common Arduino mistakes, including biting off more than you can chew. Keep it simple at first. You can always add to it later. Next, classify the project's inputs and outputs. A weather monitor might have a temperature and humidity sensor and a display of some kind. Internet projects might have a cloud service as an input, output, or both, like my Internet Valentine project, which also has a button input and LED and vibrating motor outputs for each circuit. The project I'm building today is a prop passkey evaluator that uses a membrane keypad input and outputs to an alphanumeric display as well as 3 indicator LEDs. The next step is to write pseudocode that attempts to walk through the program's main loop. Pseudocode is just plain words used to explain the program. It shouldn't be overcomplicated, but should sketch out the basic causes and effects you want to deal with in your program. Next up, select and evaluate hardware components that could work for your inputs and outputs. It's a little more complicated than just making sure you have enough pins available, but I'll save my hardware selection advice for another video. Build and run a sample for each component you're working with. This involves downloading any relevant code libraries and checking out example code that tests you've wired it up correctly. For inputs, you'll use the serial monitor to get some feedback. And then I added an alphanumeric display with an I2C backpack and 3 different colored LEDs with each with their own resistor. I uploaded the sample code for the display to verify it's connected properly, then ran a simple blink sketch to test the LEDs. In both cases, I found wiring errors that I needed to fix. It's easier to discover that something's wired incorrectly at this stage when you're working with code that's known to work with the component at hand, rather than trying to debug wiring and code at the same time. Start writing comments in your code that explain what each section does. You can create a new sketch where you'll paste in elements of all of your sample sketches to make your program. In the loop, if you don't have a good example to follow or want to write it from scratch, paste in your pseudocode as comments to start. Then you'll start to create the logical overall structure of the program. It's possible one of your sample sketches already does most of your core structure, or it might be easy to find something online that does. It's likely that somebody's already done something similar to your idea before, even if it uses different hardware. So I looked online and I found a few membrane keypad door lock projects, all using this password library. So I downloaded the library and I checked out the examples that came with it. And I got very lucky. There's a membrane keypad passkey evaluator sample that does exactly what I want. All I have to do is include my desired outputs, so code for the display and the LEDs. So now that I've found or made the basic structure of my project code, I want to start pasting in all the other elements from the other samples I tried. So in my case, it's a sample, so I'm going to go ahead and save it with a different name. And then I don't really need anything from the membrane keypad program, so I'll just close that one for now. And for the LED, so what I'm looking for is to consolidate everything before the setup, so all the variable declarations. In my case, I think I want to make some constants for the LED pins. We'll call it like red LED pin, and that's 10, and yellow is 11, and green is 12. And then we'll want to copy everything over from the setup too. So in this case, I'm just going to change the way those are represented a little so that they use the variables. See, in such a small program like this, it doesn't really matter if you use the number 10 throughout the program, but once you start getting into a bigger program, it really makes sense to abstract those into variable names. So in case you want to change the pin number later, you only have to change it one place. Great, okay, so I've declared them as outputs. One really good practice while you're doing this is to compile your program really often. That way, if there's an error, you'll be able to isolate it to just the time when you copied over such and such. Here's where it's pretty critical that you pay attention to matching curly braces, missing semicolons, and other typos that would make your program hard to debug. So now that it compiles with the pin initializations, I'm going to go ahead and add the LED function I'm looking for. So my pseudocode said that the LED starts out yellow, so I might as well just turn that on during this setup. And then, let's see, it says here add code to run if it works. So if there's success, I think let's turn the LED off while it's evaluating the password. So, and actually we also want to reverse these so that the star and the pound, the star resets and the pound checks the password. So after we reset the password, we can represent this like this instead. After we reset the password, let's turn the yellow LED off so that while you're entering the password, the yellow LEDs, there's no LEDs on. Once you press the pound button, it's going to check the password. So then it goes down to this function. And if there's success, let's turn on the green LED. And then we'll wait a second and then turn it back off. And then, you know what, let's do the red instead. Oops, this is supposed to be green. And this is supposed to be red. Okay, so now we can compile that and test it out. Yellow's on. When I press star, it turns off. Great. That works awesome. So that's my basic function. Adding the quad alphanumeric display is going to be a little more tricky. So the first thing we'll do is grab all of the libraries and stick them with the other library includes at the top of the program. I'm going to create an object for the alphanumeric display. And then serial, we're going to the setup now. The serial begin, they're both at 9600 baud. This looks like during the setup in this sample code, it runs through a bunch of tests. But this one initializes it. So we'll add that one. Clear and then write display. Why not? We could try to take them out later. And then it says display every character. We don't really need to do that. And then we're not sure that we need this display buffer either. I don't think any single word sample code came with this code library, but I can think of a project I've seen. Yeah, LED knuckle jewelry, so where it prints like a whole word that's 4 characters long. So here's the part where it just displays, and then, oh, and then here's a simple scroller too. Interesting. Okay. Well, I've made it so it's only 4 letters, so we'll grab that, put it into the success is open. And then again for unsuccessful is nope. And then let's see, we'll want to clear the display after the minute, after the second's over. So there, that. But just because your program compiles doesn't mean it does exactly what you want yet. For instance, I had mixed up my red and green LEDs when I first made this project. There will undoubtedly be unexpected issues that will come up once you put all the elements together and you actually see how it's working. You might change what you want your program to do. This is the nature of coding. You'll want to keep track of your different iterations, so be smart about how you name your files. I recommend using version numbers. When you get to a milestone, name it version 2, then save a version 3 and start making new changes. After your base project is working, then it's cool to go ahead and add any other features from your nice-to-have list or others that you brainstormed during the build. Thanks for following along. If you liked this video, please give it a thumbs up and subscribe to catch my future projects about technology, crafts, and my life here in New York City. See you next time.